Normal forecasting models used by people like the Met Office are based on global observations of the weather, fed into a computer model that will, in a mathematically rigorous way, conserve the energy on the planet. They'll conserve the water, and everything else will be done in a way that is physically realistic, and they'll produce a forecast which is consistent with the observations but not exactly the same as the observations. But you can't use the observations exactly as they are because they're slightly in error, and if you did use them that way, then you would start adding energy to the world or destroying it in a way that's not physically realistic. So the GCMs bring the data into a form where it's producing a forecast that is physically realistic, may not be perfect, but it's conserving all the information that it should be conserving, and it's doing the physical representation in a scientifically rigorous way. The problem is that forecasting models are always changing through time because people are improving the forecasting models. So occasionally people run what's called a reanalysis, where they take one version, the latest version of their forecasting model, and they take their library of daily observations and they run, using that one version of the forecasting model for many decades, the forecasting procedure again, but it's always one version of that forecasting model instead of constantly changing it. So they then get their best guess of what actually has happened given their up-to-date forecasting model and their library of observations. The observations also change so that, for example, satellites become available and different types of satellites become available, whereas they weren't available in the early 80s. So you can see that the product is actually a more consistent timeline, if you like, of how the weather has changed for decades. Now, this approach to this forecasting product is called a reanalysis. Different people have produced reanalyses in the past, and we've used one produced by the ECMWF, which is the European Centre for Medium Range Weather Forecasting, which is also in Britain, but it's an international organisation based in Europe. Their data set, it forms the basis of the watch forcing data. Unfortunately, it's at 1 degree spatial resolution, and we wanted a higher spatial resolution. So one of the things we did to their data was change it so that it's appropriate to a 0.5 degree spatial resolution. So we get down to this 50-kilometre scale. Also, the observations they use are mostly made in the atmosphere. And often you find that although the GCM, the forecasting model, does the best job it can, and it's very good at doing the atmosphere, the information near the surface, which is where the hydrological models need to get their data from, is often inaccurate. It may be too high for temperature, for example, or too low for temperature. And so one of the things that we have to do to produce data which are as good as they can be for the hydrological models is we need to use available surface observations. So, for example, whether or not it was raining or snowing. For example, what the average temperature was, and so forth. And these type of data are available at 0.5 degree as it happens, but on a monthly time step. So we can correct the monthly average behaviour of what's come from the reanalysis to be consistent with the observations. So we take the best guess from the reanalysis, and then we say, but we need to have this average, not that average, for example. Cloudiness is another thing that's important, and also aerosols are very important as well. There have been long-term changes in the particles in the atmosphere. A lot of it has to do with industry, and there are very slow changes. There are seasonal changes, but there are also decadal-long changes in how much light is getting from the sun down to the land surface, and that's affected by the particles in the air, these aerosols. And so one of the many changes that we've made to the reanalysis is to allow for that, because that wasn't incorporated in this forecasting model.